Okay, hello everybody. Back again. New bug to look at. This one looks pretty interesting. So this is a Stack Overflow bug in a project called Q. Once again, never heard of this or used this before. Q appears to be a kind of combination of a data language and a data validation language, where it has a bunch of constructs for applying constraints to data files, and you can evaluate using this eval tool. You can evaluate expressions within the evaluated files. So the syntax is not very familiar to me. I have a hard time kind of parsing and seeing what's going on, but we'll give it a shot anyway. In particular, the user who reported this bug mentioned that this is a little odd in that it only occurs when you output using this YAML Marshall stream. The same command using the JSON marshaller does not cause this Stack Overflow. So we're going to have to look at that as well. Given that there is a whole repro here, I think first thing that we should do is get the project cloned, get it building, see if we can get this repro running, and then figure out if we can find out where the Stack Overflow is happening, which particular stack frames are repeating. So let's get going. I believe the project is written in Go. So let's check contributing guide really quick. Go test. If quite the contributing guide. Garrett. Garrett Hub for Code is a powerful review interface with comments that are attributed to patch sets. So I might have to use Garrett for sending the GitHub PR. Oh, or not. It seems like GitHub pull requests are also supported. I don't see any documentation on kind of getting a development environment up and running. So I believe let's just see if standard commands work. No Go files. Compile package. Nothing. So where are they running it? Yeah, so I just have to run it in one of the subdirectories. Now, the tool that we are testing here, we're executing Q using this eval thing. So this might be part of the command package. It might be part of the Q package. Let's build. I don't see. SQ. Command.main. Eval? Yeah, so this looks like what I need. And now we have a ./q. Perfect. So let's go back to here. So we wanted to go into command/q and go build. Yeah. Then we need to get some of these files locally. So the files are going to be repro.q. Let's go here. Copy that. Stdo.golden, I think, is this making, this is generated, right? No, okay. Let's do this. Golden. Then I think this is also actually part of the repro. Partial.golden.partial. Let's see. So now we have that file, we have that file, we have this file. And the only thing left are the commands. And so let's go back to repro, paste these. Now Q is going to be command Q /Q. This is going to be command Q Q. This is going to be command Q Q. And let's do repro clean and do repro because I think this was meant to be separate cases. Let's do this. And this. And so if I understand this setup correctly, we should be able to do repro clean.shell, and it should cannot find package ./repo row. Repro/repro. Okay, so I think looks like it needs its own directory because this is in repro/. So let's try do this and move this into here and see if this works. Okay. That looks like the expected output. Did not generate a stdout file. And did this generate anything? Because this is the entire golden file, I believe. So let's get rid of this and see what happens with just this one. Syntax error. Line 6. This is unmatched. This does seem like it's supposed to be here. Okay, so that's the working version. And the overflow version does not have the same issue, and it does crash. Now, the okay, we have a Stack Overflow, which is what's expected. We have evaluate, node context, insert conjuncts, add expression conjunct. So what's interesting here is I don't see anything related to the YAML outputter, at least not yet. And so it's a little surprising that even though that's what changes the behavior, we don't see the YAML code path, at least yet, anywhere in this stack trace. Now, YAML Marshall stream. Okay. So this might be a place to check. This seems really far down the stack, though. So one thing I'm going to do is I'm going to check and see whether, just for sanity's sake, if there's an easy way to change the Go stack size limit and then run the other JSON case. And if we run the JSON case with a slightly smaller stack, does it also do the same thing? Because that kind of would exclude the YAML versus JSON difference. And the stack that I'm seeing at least seems like what's repeating stack frames doesn't have anything to do with the YAML encoding. We have one stack frame related to YAML, and then everything else seems possibly unrelated. So let's do a quick Google search. Golang override stack size limit. Go routines and Go can be monitored using runtime debug. 1 gigabyte. 250 megs. Is that really how big the stack is? It exceeds 1 gigabyte. That's wild. That's huge. Runtime /debug. Okay, let's give this a shot. So command Q go, and then we're gonna do maybe 16 megabytes, something quite a bit smaller. And we're going to do the same thing again. And I'm guessing, yeah, we're going to run into the same error. But now if we do repro clean, it still works. Okay, so there's a huge difference in stack size, where the clean implementation using JSON.Marshall is working properly with less than 16 megabytes of RAM, and the YAML one requires more than a gigabyte. I'm going to run the same test again, but this time I'm actually going to increase the memory limit to maybe 4 gigs, and this should still work. And is this going to work now? No, still not. Oh, okay. That's something that I didn't notice the first time. Is where did it say it? There was a message that said something about elided. Yeah. Okay. So 8 million elided frames. Now we have YAML. Okay. Well, let's first off compare the YAML marshaller with the. Oh, this is built into Go. Interesting. Q package encoding YAML manual.go. Okay. So in this case, we are importing QLang internal encoding YAML. Okay. And manual.go line 53. B.syntax. Q.final. Q.concrete 2. And the issue is in the syntax call. Syntax. Comment. Syntax converts the possibly partially evaluated value into syntax. This can be used to print the value with package format. This turns AST node is going to be a Q type, right? Yeah. So, and the options here are not option. This is also a Q thing. Option, concrete raw has hidden just a bunch of booleans. So, Marshall stream returns the YAML encoding of V. I equals 0. Iter asynchronous processing. We get v.list. We iterate over the list. Validate syntax. And we write, we do the YAML encoding for this value. Encode. Okay, nothing here seems that wild. So you export, nip, pivot, visit reusing visitor. Visitor. Mark conjuncts. Mark conjuncts. Visit leaf conjuncts. Conjuncts. Resolver mark or dependency. Internal resolvers. And mark conjuncts again. Is this what's going to repeat? Internal resolvers. Mark conjuncts. Seems like it. Okay. So let us see what the JSON format looks like in manual. So does this do something similar? Marshal stream, iter.next, internal JSON.marshal, iter.value, write p, write byte. So the implementation here is much different than the implementation in the YAML one. So this has QYAML.encode, and then we write B. But here we're encoding this, whereas in the JSON one, we are just encoding iter.value. So I do B equals iter.value. This, get rid of that, and run this again. Cannot use V as ast.node value. Q.value does not implement that. So in manual, we get Marshal, and here we're marshaling a value in the list. Okay, so now we're into Golang standard library stuff. And so we're just doing the normal JSON encode of whatever the value is. Now the YAML encoding expects this to be an AST node. And the iterator is a value. And is there a way for us to turn a value into a AST node? Syntax converts the possibly partially evaluated value into syntax. This can be used to print the value with package format. Okay, so this makes sense now. Kind of. It definitely seems like this is definitely a point where we could go back to the bug already and say that we now understand why the two formats are so different, or the two behaviors are so different. In the partial case, we're just printing name version. Why can't we do something similar with YAML? So this didn't work. We do validate. Concrete ensures that all values are concrete. For validate, this means it returns an error if this is not the case. In other cases, a non-concrete variable will be replaced with an error. So we already validated that the value itself is concrete, which seems like it means like it should have entirely specified. It shouldn't have like logical nodes left over from the Q syntax. It should just be kind of a dictionary of values. And so that seems like it should be the easy case for syntax to convert. So final indicates a value is final. It implicitly closes all structs and lists in a value and selects defaults. Ensures that all values are concrete for validate. In other cases, a non-concrete value will be replaced with an error. Okay, so in stack trace, we get to YAML, Marshall, syntax in types.go, and we go to vertex. V is a value, v.instance.id. P.vertex. If O, so what is O? O is get options. If O.concrete or final or resolve references, then we do P.vertex. If error isn't nil, and is this 874 where we're getting the export.go 256874, yeah. Okay, so V is the value. Runtime. V.adt.vertex. He holds any value, which may be a Boolean, error, list, null, number, struct, or string. We get the runtime. We have a vertex, which I don't know what that is. Parent keeps track of the parent if the value corresponding to v.parent differs recursively. A vertex is a node in the value tree. It may be a leaf or internal node. They have arcs to represent elements of a fully evaluated struct or list. Definitions in concrete fields. Optional fields are dropped. It maintains source information such as a list of conjuncts that contributed to the value. Okay. New exporter. Init pivot value. So this is good. 258. Is this where we get to export.go 256? Exports evaluated values. It resolves incomplete references that point outside the current context. How often is this syntax used? Attributes, final definitions. So it is used. Okay. So we're here, here, you go here. Self-contained. This might be root. This seems interesting. E export.profile. Fragment is o.raw. If we go to annual.go in YAML and we pass q.raw, true. This. Let me try again. This one, version v1. Raw tells syntax to generate the value as is without any simplifications and without ensuring a value is self-contained. Any references are left dangling. The generated syntax tree can be compiled by passing the value from which it was generated to scope. Inline imports overrides this option with respect to ensuring the output is self-contained. Okay. Not sure. So we don't get here because it's not a fragment. And then we get to init pivoter. And his link dependencies where the comes up. Marshall init. Yeah, link dependencies. Arcdeps. Link dependencies. Arcdeps. There's no need for recursive checks. Node. Just mark depths. Repeat. No, it's the first one that repeats. It's going to be visit, reusing visitor, visit leaf conjuncts, arc conjuncts, visit leaf conjuncts. Why is visit leaf conjuncts recurring? That sounds, if it's a leaf, shouldn't it be done recurring? Visit leaf. Visit leaf conjuncts. Visits all conjuncts that are leafs of the conjunct group. F. Visit leaf conjuncts. A vertex. Use proper accessor for conjuncts. Visit leaf conjuncts. This was visit conjuncts, v.conjuncts. Not Okay. Basics. And YAML manual.go. And let's get rid of raw. And this is still going to error out. Okay, so this code change does not appear to be the reason why. Okay. Is it conjuncts? Is it x equals c dot x? Type. Conjunct group. Is it conjuncts? And the issue, though, is it happening in the callback of visit? We're supposed to be doing visit leaf conjuncts, but this just calls, is it conjuncts, which calls mark internal resolvers. Marks dependencies for rootless nodes. These nodes may be visited during no. Their objects. C.marked as let's have no path, and we otherwise will not process them. We set processing all to true. Expr retrieves the expression form of the contained conjunct. Mark expr. Mark. If c.marked isn't nil, saved equals c.all. All indicates what the process references that would be unified into different fields. This is similar to recurse, but sometimes gets temporarily overridden to deal with special cases. V. Already process all values recursively, so disable while processing in this case. It seems a little odd that we're not doing this down here, but the issues coming up in this Mark Expra. Mark Expra, Mark comprehension, which calls Mark Expra, or to dependency. And so at some point, we have to have marked is this mx equals true. This seems like exactly the issue. This might be exactly what's going on. It looks like we're marking x, but then doing all this work. But if x is already marked, then this work has likely already been done. So can we do something as simple as doing if one map read? I always forget this. Yeah, it's this. Okay. If marked exists, I think, is equal to mx. Is this marked? Then do we just return? No, not that simple. So we still have an issue with Mark Expra getting called over and over again. If marked and exist, it exists and it's marked. Turn. Pretty sure that's right. Yeah. In an expression to mark dependencies. So that's not the problem. So we do mark resolver. From here, I don't even see. Mark expra def.go 285. A different mark expra. Okay. And this goes into here, which is the one path that isn't short-circuited in the resolver check. That makes sense. Mark resolver. Resolves dependencies. Resolve a contact. Unreachable. And are okay to pass term closure. It's simply marking the expression So same thing. Do we have a marked? We do. But why isn't this using it? It's not using this at all. C dot marked and all. Saved, marked. C dot marked is nil. Marked, don't mark expra. Oh, I see. Marked, mark expra. Okay. And here, do we do C dot mark expra? This is still very, very strange. This, where was this found? Find references. We only do it here, which is marked internal resolvers. Processing all to true. So this, what's M? M is marked, so we go recursively. Then we mark conjuncts. This calls this, which is this case. And I just don't quite, we're calling mark expra. I want to mark a resolver. And then this calls mark expression again on mixers. Mark resolver, report dependency. So the case where an inline concept does not resolve, but has reference. Result in failure during if B is not found. Okay. Report dependency reports dependency from R to V. E must be a value that is obtained after resolving R. And the branch that we care about is mark internal resolvers. Here, on 580. Evaluate inner. Oh, I see. Mark resolvers 580. Or dependency 441. Which calls mark internal resolvers. Env ref v. Does v ever change in this little process? Equals w. Yes. So it's possible that mark internal resolvers gets called for different values of v. Although only kind of, because v only changes afterwards. Rooted. Node must not be rooted. Then we do evaluate inner, which at some point is going to call mark conjuncts, which calls mark expression, which gives us this. So do we end up with the same resolvers? That's, I guess, kind of the question, because this mark resolver does mark resolver show up multiple times, or is it only mark internal resolvers? Mark internal, inner comprehension, mark internal, mark internal, and mark internal resolvers takes the parameter, so we can't just cache if c.marked. And then we slap pair. Make this available as a property of vertices to avoid doing it repeatedly. Visit the leaf conjuncts. Expression. But nothing here takes into account v. So even if v is changing, none of this matters. That's the one that I've already short-circuited. This shouldn't be causing, but is it still in visit leaf conjuncts? Yes. Visit leaf conjuncts calling, but it's not in the callback. No, it is, because the callback is mark internal resolvers. That's only called from report dependency. Mark conjuncts. Func2 diptyco 545. Mark expra. Mark resolver. Mark conjuncts. And then we go to 285. That's mark resolver. $285. Then we mark resolver. Eventually we get up to mark internal resolver. internal resolver. Yeah, mark resolver, mark dependency, mark internal resolver. So mark resolver. More dependency. Yes. Env R is the resolver. And ref, the environment and the resolver. Does the environment ever change? Yes. Something here has to be cacheable, I think. Mark the resolver. Port dependency. Mark internal resolvers. So here we have the vertex. Here we have the ref. In mark resolver, we have an environment and an expression. The fact that the environment can change means we can't just depend on actually, can we? Like if it changes, change this, then we visit all these, and these are all sub-expressions. How many different places do we do n equals? Here we never recurse with a different env. Mark comprehend, mark clauses. Yeah, here we recurse using a different environment, so we can't assume that stays the same. So two. So it's still going through this path, which means the expression is changing every time. And then we're going from here to 85. No. Mark expra 285. This is the other mark expra. I keep getting, I think my symbols sometimes are taking me to the wrong spot. Mark resolver. Or dependency. R ref. From are the issues with the dependencies from environment, R being the resolver, and ref is this. So an environment and a resolver. Um, type struct env environment and wait, it's a ref entry. Resolvers. Map ref entry. Cool. So it's a interface, right? Yeah. Okay. Marked make map ref entry rule, I think. And then resolvers. Here. Entry. Of our entry dot env equals env and 3 dot ref equals r if marked exists c marked resolvers entry marked and exists return. Oh, I forgot to set it. Okay. That works. So once again, I think I have a enough to write a bug, but I certainly am not confident. Sorry, I have enough to write a comment on the bug, but I certainly don't feel confident that this is a reasonable solution. It's definitely clear that we're redoing work that we don't have to do. And by caching the resolvers, we can avoid that. I'm not sure why. I'm not sure if this is the correct fix. I'm not sure if it's a new issue. Yeah, but that's what's going on. So let's at least write up a comment. I'm probably not even going to package this code up in a commit. Actually, I'm probably just going to write the comment. Let's see what I can do. Spent some time digging into this bug. Where was it? Jason. Jason and yeah, our colors are very different. JSON marker and convert directly from a iter value from a q.value value resulting JSON. However, the YAML marker needs to convert the q.value back to a syntax and it is that process which is causing Stack Overflow. I came up with two workarounds which seem to address which mitigate the overflow, but I'm not sure which, if either, are correct or suitable. Passing q dot raw as an option to the syntax conversion in the YAML in YAML Oracle stream operation skips the portions of the syntax conversion which are causing the overflow for the however, this probably still exists for other syntax versions. Second, the work in the overflow is caused by a, still don't know what the smallest subset arc resolver dependency internal leaves internal by infinite the excessive order is caused the arc resolver and or dependency of the string arc resolver and import dependency. The work in arc resolver specifically seems to be getting repeated, having a map visitor, a map ref entry bool to visitor and failing early from the arc resolver implementation if the environment resolver pair have already been marked. Marked also resolves the issue. I guess I might as well upload the code to a private branch and to my repository and at least link it. Fork. RM repro. RM I should have tried this without my without this change. Let's just push them both up because I think this seems to me like a bug, but I could very well be wrong. Explorations fixing stack overflow in YAML partially. This YAML marshalling. Yes, slash GUI. Remote add LornVS git at github.com, LornVS slash GUI.git. Repository not found. FE, github.com, LornVS. It's not GUI, it's Q. It's update. There we go. That should do it. Okay. You commit. You. I also noticed the ArcExpra path in seems to be missing an early return if the expression has already been marked. However, adding this didn't resolve the see the changes I've experimented with in this. Okay, I think that's basically it. Once again, this is not sending out a PR, but it's doing a bunch of investigation. And I think I'm pretty happy with how this went. This project I think is relatively difficult to approach. There was a lot of terminology that I wasn't that familiar with, and just trying to, in this whole chain, we were looking at something that wasn't really directly related to YAML. And I have a feeling that a lot of the work that was happening here is completely unnecessary for the YAML marshalling. And so this might actually be a good option in that path. But even if the maintainers went this way, I feel like there are still bugs in the syntax conversion that might surface in other places. Regardless, this was pretty fun. And thanks everyone, and I'll see you next time.